Hello students, last time we learned about square numbers, and in this video we'll be learning about how to find out square of any given numbers. So suppose the question is find the square of a number. Say this is the question given to us, like 2, 4 and 9. We have to find the square of a number. We know that the square of a number means we need to multiply the same number twice. So for A, 2 square equals to 2 into 2, that is equals to 4. Likewise for B, 4 square equals to 4 into 4 equals to 16. C, 9 square equals to 9 into 9 equals to 81. It's quite easy, isn't it? But if the question is given as find the square of the number like 21, 53, 18, can you tell what is the square of 21 or 53 or 18? Now we'll learn about how to find out the square of such numbers. Today we'll be learning about how to find out the square of such numbers. So there are methods to find the square of any given number. Let us learn the method by using algebraic identity. Suppose you have 21 square, so you need to find out what is 21 square. So 21 square can be written as 20 plus 1 whole square, because 20 plus 1 is 21. So there's a square, so it's the same thing. Now we know this identity, a plus b whole square equals to a square plus 2ab plus b square. So 20 plus 1 looks like a plus b. So here we have a equals to 20 and b equals to 1. So a plus b whole square equals to a square plus 2 into a into b plus b square. So here in place of a and b we'll be replacing by the number 20 and 1. So 20 plus 1 whole square equals to 20 square plus 2 into 20 into 1 plus 1 square, because a is 20 and b is 1. Now 20 square is 400 and 2 into 20 into 1 is 40 and 1 square is 1. So 400 plus 40 is 440 and 1 is there. So 440 plus 1 is 441. Therefore 21 square is nothing but 441. So the square of 21 is 441. Let us have a look at another number, 99 square. Suppose you are supposed to find out the value of 99 square. So again 99 square can be written as 100 minus 1. Previously we wrote 20 plus 1. Here we are writing 100 minus 1, because it's easy for us to find out the square of 100 or 1, that is. So here we'll be using the algebraic identity, a minus b whole square equals to a square minus 2ab plus b square. In the earlier question we did a plus b whole square. Here we are doing a minus b whole square. So a here is 100 and b is 1. So in place of a we'll be replacing by 100, and in place of b we'll be replacing by 1. So using this identity a minus b whole square, we'll try to find out the square of 99. So 100 minus 1 whole square equals to 100 square minus 2 into 100 into 1 plus 1 square, because a is 100 and b is 1. 100 square gives us 10,000, and 2 into 100 into 1 is 200, and 1 square is 1. Now 10,000 minus 200 is 9800, and 1 is there. Now 9800 plus 1 is 9801, that is the square of 99 is 9801. So this is the method to find out square of a number using algebraic identity. Let us look at another method, that is by direct multiplication. Suppose you are supposed to find out 21 square. Again, we are taking the same example here. 21 square is nothing but 21 into 21, because squaring a number is actually multiplying the same number twice. So 21 into 21. 1 times 21 is 21, and 2 times 21 is 42. So when we add these numbers, 21 and 42, we get 441. You very well know about this, and you can do it very easily also. So the square of 21 is 441. We also got the same number using algebraic identity also. So now you know how to find out the square of any given numbers, either by using identity or by directly multiplying. Let us learn about this topic, Pythagorean triplets. You have heard about Pythagoras. He was a great mathematician. So we'll learn about Pythagorean triplets. Triplets means 3. So Pythagorean triplet meaning it is a collection of 3 positive numbers or integers which satisfies the Pythagoras theorem. So we have to have 3 different numbers which satisfies the Pythagoras theorem. Now what is Pythagoras theorem? It says the sum of the squares of 2 sides of a right angle triangle is equal to the square of its hypotenuse. Let me repeat again. The sum of the squares of 2 sides of a right angle triangle is equal to the square of its hypotenuse. Let us try to understand this by taking a right angle triangle having a perpendicular, hypotenuse and a base, where perpendicular is considered as A, base is B, and hypotenuse as C. We must take care that C or hypotenuse is always the longest side. A and B can be equal or can be unequal with each other also. So as per the statement of Pythagoras, perpendicular square plus base square equals to hypotenuse square. We can write this in short like p square plus b square equals to h square. In place of p we can write a, and in place of b we can write b, and in place of h we can write c. So a square plus b square equals to c square. A and B and C, they are the sides of a right angle triangle, where C is the longest side, so we'll consider C as the hypotenuse. Let us consider a right angle triangle here having these sides 3 cm, 4 cm and 5 cm each. Now we have the Pythagoras theorem as a square plus b square equals to c square. Now a is 3, b is 4 and c is 5. So we'll replace a, b, c with these values. So 3 square plus 4 square is equals to 5 square. When we say these numbers satisfy the Pythagoras theorem, we actually mean that a square plus b square, which is on the left hand side, should be equals to c square, which is on the right hand side, meaning these numbers should be equal in both LHS and RHS. Now 3 square is 9 and 4 square is 16 and 5 square is 25. 9 plus 16 is 25, and on the right hand side we have 25. So we see that when we do this, when we square and sum, then we get 25 each on LHS and RHS, which are equal to one another. So we say 3, 4, 5 satisfies the Pythagoras theorem, or we can say 3, 4, 5 are the Pythagorean triplet. So now I think you are getting it. What is a Pythagorean triplet? In this lesson, we will learn how to find out Pythagorean triplet if one of its number is given. For example, the question says find the Pythagorean triplet if one of the member is 6, meaning 6 is the Pythagorean triplet, one of the Pythagorean triplet. We need to find out other two numbers. Before we proceed, we must understand and we must find out the value m, any natural number, which will satisfy this equation, that is 2m square plus m square minus 1 whole square equals to m square plus 1 whole square, or simply a square plus b square equals to c square. So by this statement we can say that 2m, m square minus 1 and m square plus 1 will form the Pythagorean triplet. Or furthermore, we can say 2m may be equal to 6, or m square minus 1 may be equal to 6, or m square plus 1 may be equal to 6, meaning the number that is given to us in the question should be equated with all this value, and we should find out the value of m from this equation. Let me consider 2m is equals to 6. Whenever we transpose a coefficient of a variable, that is the coefficient is 2 here and the variable is m, we transpose and it divides the number which is already on the right hand side. So the new equation becomes m equals to 6 by 2, and 2 times 1 is 2 and 2 times 3 is 6. So we get the value of m as 3, and 3 is greater than 1, and it will, or it may satisfy the equation that is given to us in the second line here. So we can finally say that the value of m is equals to 3. After getting the value of m equals to 3, this 3 will give us the second and the third member of the Pythagorean triplet. To find out the second and the third Pythagorean triplet, now we must put the value of m, that is equals to 3, in the second and the third possibility, that is m square minus 1 and m square plus 1. So m square minus 1 will give us the second member. Now we know that m equals to 3, so replacing the value of m as 3, we get the second member as 3 square minus 1. Now we have 3 square as 9 minus 1, and 9 minus 1 is nothing but 8. So we found out the second member as 8. Now the third member should be equals to m square plus 1, and we know m is equals to 3. So replacing the value of m as 3, we get third member as 3 square plus 1, and 3 square is 9 plus 1, and 9 plus 1 is nothing but 10. So we found out the third member of the Pythagorean triplet as 10. Now let's see whether it satisfies the Pythagoras theorem or not. We have the first member as 6, so we can consider this number as a because it's the smallest one. Second member b, that is 8, and the third member c, which is equal to 10, and this is the highest number, so we can consider this to be the hypotenuse because we know that hypotenuse is the longest side. The Pythagoras theorem says that a square plus b square equals to c square. We are verifying whether 6, 8, 10 are the Pythagorean triplet or not. So we'll replace the value of a, b and c by 6, 8 and 10 respectively. So we get 6 square plus 8 square equals to 10 square. 6 square is 36, 8 square is 64 and 10 square is 100. Now 36 plus 64 is nothing but 100, and on the right hand side we already have 100. So we see that LHS is equals to RHS, meaning 6, 8 and 10 satisfy the Pythagorean theorem or Pythagoras theorem. Let us understand this method of finding Pythagorean triplet by taking another example. Say one of the members is 8, so we need to find out other two members of the Pythagorean triplet. So 2m, m square minus 1 and m square plus 1 will form the Pythagorean triplet, and 2m may be equal to 8, m square minus 1 may be equals to 8, or m square plus 1 may also be equal to 8. We have to consider all these three facts with the given Pythagorean triplet, and then we need to find out its the value of m from this number. I'm considering 2m equals to 8. When I transpose it, it divides the number 8 on the right hand side, and I get m equals to 8 by 2. 2 times 1 is 2 and 2 times 4 is 8. So the value of m is 4, which is the positive integer, and we can consider m as 4 after finding out the value of m as a positive integer, not as a fraction or decimal or a complex number. Then we can easily find out the other two Pythagorean triplet. So the second member is m square minus 1, and we know m is equals to 4. So replacing the value of m as 4, we get 4 square minus 1, and 4 square is 16. So we get 16 minus 1, and 16 minus 1 is 15. So 15 is the second member of the Pythagorean triplet. The third member should be equals to m square plus 1, and m is 4. So replacing the value of m as 4, we get 4 square plus 1, and we know 4 square is 16, so we get 16 plus 1, and 16 plus 1 is 17. So 17 is the third Pythagorean triplet, or the third member of the Pythagorean triplet. Now let us see whether these numbers that we found out earlier will satisfy the Pythagoras theorem, that is a equals to 8, b equals to 15 and c equals to 17. It is the largest number, so this is nothing but the hypotenuse of the right angle triangle. So for the verification, we know a square plus b square equals to c square, that is the Pythagoras theorem. So replacing a, b, c as 8, 15 and 17 respectively, we get 8 square plus 15 square equals to 17 square. 8 square is 64, 15 square is 225, 7 square is 289. You can find out the square of 15 and 17 easily by using the method that I taught you earlier, and we get these numbers. And when we add 64 plus 225, I get 289 on the LHS. On the RHS we have 289. So we see that LHS equals to RHS, so satisfying the Pythagoras theorem. Therefore 8, 15 and 17 is another Pythagorean triplet. There are so many Pythagorean triplets we can easily find out by doing the same method. That is, we can equate it with 2m, m square minus 1 or m square plus 1 to find out all the member of the given Pythagorean triplet. So this is how you find the Pythagorean triplet, and this is how you find out the square of any given number. So thank you for watching this video. I hope it helps you a lot. I'll be uploading another video in which I'll be discussing on how to find out square roots, what are square roots, and thank you so much.